Hello, and for those of you watching this recording, since I don't have anybody showing up in person, the first session we had about a couple people there, mostly on Zoom, but I did make a recording of the first session, which was last month, but there was a lot of interruptions, and now I think I have an opportunity at a clean recording. So for those of you watching, thank you for taking time to watch and regarding neurodivergent learning. So I'm going to kind of recap a bit based on what I went over last time. So in terms of understanding fundamentally, what does learning mean, and not to stereotype learning to be having to do with going to school, be it dealing with public and higher education system structures. I want people to get more of a grasp of understanding that learning has more to do with a generalization of how we constantly engage with the world around us, and we're constantly bombarded with sensory inputs, and then our brains are constantly trying to calibrate to stimulus that they're presented to in our surroundings, and then we have to respond to that in some respect, right? So on the one hand, we perceive the world around us, we develop a sort of model in our heads about, okay, how do I navigate the world around me? And then we act upon that. So we have actions in terms of how we interact with our surroundings, how we interact with others. And then there is also this capacity to anticipate or try and figure out, okay, how should I calibrate how I perceive the world around me, and how should I follow up with that perception in terms of how should I act in sequence accordingly? What are the next sequences of actions that are appropriate according to the model that I've developed, the abstraction thereof, because everybody perceives the world around them differently, and the whole purpose of the generalization of learning, or coming to an understanding rather of, okay, what is a generalization of what learning means, rather than subjugating it to stereotypes. And what learning really means is, how do we constantly adapt to changes in how we engage with our surroundings, and in terms of how we approach everyday life, the tasks we do, the responsibilities we have. Learning has much to do with how do we sustain fitness, or a general level of satisfactory capacity to engage, which is constructive for our lifestyle moving forward, right? So how do we constructively engage with our environment in a way that is intuitive rather than counterintuitive to fitness, survival, how we engage with the world around us. So really, learning has to do with this capacity to navigate and maintain fitness, and how we perceive and act and anticipate accordingly, which best attenuates fitness and adaptation. So that would be a general understanding of, okay, what does learning mean? So I could get more into the depths of this. So before I make any other remarks about what learning means, what exactly is the point of hosting these sessions? So, like myself, there are many other people that struggle with neurodivergence, interacting with how information is presented to them in a manner that is constructive and intuitive for the person in which the information is being presented to, right? So if I'm in school, or I'm working with other people on a project, or whether it's employment related, right? This capacity to engage, not just in a general sense with my surrounding environment, but to engage with the world around me in a way that is not standardized. I don't want to say non-formal. Informal really has to do with how we break down how information is presented to us through reasoning, how we reason about that information. And so the whole point of these sessions, and this is the second session, by the way. I hosted the first session last month. There wasn't much of a turnout, but since it doesn't seem like there's going to be a turnout this time around, I think this is going to be a nice clean recording for those who would be interested in joining future sessions. We're going to deep dive into more the theme of this session, which would be leveraging, okay, how can we utilize creativity or really art as a mode to engage with the abstraction of information. And a lot of how we deduce, how we navigate the world around us has to do with reasoning, or we could talk about how mathematics is so important in regards to this capacity to reason, but instead of going deep into the woods of what mathematics is all about, and to really shortcut that for those that really don't want to go deep into the woods right now because they don't have that sense of motivation. And I get it, and I get that a lot of people that even don't struggle that much with neurodivergence, they're going to struggle trying to engage with understanding some kind of information in some way or somehow, because either they don't have the motivation to engage with that information, or they just don't have that intuition or some sense of intuition that works for them developed, where they can in some capacity engage within reason with that information. And there's limitations to how we engage with information, and if anyone was to go deep, just try to plunge down the hole of mathematical understanding or the physical sciences, there's really no absolute understanding of the world around us. It's really all interpretation. And I don't want to say that in the most, I guess in the most general sense. But we could consider that because the interpretation is not absolute, it is relative to the interpreter, right? It's relative to me, how I interpret the world around me. It's relative to how someone else that isn't me that interprets the world around them. So that's what I mean by not absolute. We develop these generalizations to pick apart the world around us and navigate circumstances, and the physical sciences helps us model experiments to appropriate these generalizations on the one hand, but the physical sciences also relies on abstractions of relational structures that we develop by making associations between things in our surroundings, or some kind of association that has to do with some kind of space and reasoning about that space that helps us navigate circumstances, right? And mathematics really is the bread and butter to this, because mathematics is all about coming up with a structure that represents some grouping of relations between associations, right? And we can think of all kinds of relations and associations, but that's the general gist of, okay, in terms of reasoning, we have mathematics, we have this generalization that the physical sciences provides interpretation for, or physics, but not to generalize all of the sciences, right? Because science really has to do with modes of prediction, and when we get back to what prediction means, it's really talking about anticipation, about in terms of calibrating our perceptions and how we are to conduct proper sequences of next actions. And so it's like this loop of, okay, I perceive the world around me and figure out how I navigate circumstances on the one hand, and on the other hand, I act in accordance to engage with the world around me that aligns with perception. And then I have to predict, okay, well, based on patterns or ways I'm interacting with the world around me, this is what is going to be optimal. So trying to optimize, right? Figure out, okay, in what effective manner can I constructively and intuitively engage with the world around me. Now, kind of going home about, okay, how are these sessions going to be helpful for people? Well, a lot of people that struggle with neurodivergent learning are going to probably find hopefully a lot of insight in what these sessions bring about. And unfortunately, since not many or no one's really here, so I'm just doing a clean recording, I do hope to have some open dialogue in the future, in future sessions. So I try to leave room in future sessions to have an extended dialogue regarding what does learning mean to not just me, but everybody else in the relative sense. Now, I think that's a general emphasis on, okay, what's the motivation, or I've approached a general emphasis on what is the motivation behind these sessions and how is it going to be helpful, right? Because on the one hand, standardized learning environments can be very helpful for many people, and a lot of people, they intuitively engage with curriculum structures presented in both public and higher education environments, and that's great for people that benefit from that, but it's not so great for people that have some manifested talent or some way where they can provide leverage to their communities, engage with information, and figure out ways to better help their surrounding communities. And it's not just about helping ourselves, but also helping each other. So, and that's what really gets me passionate and motivated about hosting these sessions, is bringing up this awareness that, hey, we need to start figuring out how can we better leverage information, and how can that better help people that do struggle a lot with interacting with curriculum structure systems that are embedded within our public and higher education institutions. It's not to say that these institutions are evil, but it's just that we need to spread awareness that these institutions don't work well for everybody, and the way they function is quite adversarial to how people who struggle on the spectrum of neurodivergence, whether it's autism or ADHD, I would imagine most people that are really struggling are more on the autism side than the ADHD side. But there's some overlap. I'm not going to get into that. But I just want to emphasize that, okay, what is the point of these sessions, and what kind of value, what kind of proposition that I think is important in terms of, okay, we need to spread awareness, and how can we help communities of people, especially people that are struggling with learning. And this also extends beyond neurodivergence, but also how we develop artificial intelligence technologies, right? Like insights into how we engage with each other, and modes in which people that struggle with standardization, like this, people that struggle with standardization, this could provide insights into artificial intelligence research, as I've been having lots of discussion, mostly on servers, regarding, okay, well, learning is interesting and and it's much more complicated than just engaging with information for the sake of engaging with information. Okay, well, I want to kind of, before I really get into the theme of today, which is art, I want to kind of do a recap, a little bit of what went over in the first session. So in the first session, I introduced two technologies that I think would, for people that are not totally aware of the existence of these technologies, I think these technologies are just going to be so amazing to introduce to people that are, on the one hand, struggling to keep track of information. So this is Trello, and I'm just going to do a really quick rundown of Trello. I had some interruptions last time, but I want to introduce Trello, and then I want to introduce a generative AI tool known as ChatGPT. I have the next tab, of course, is ChatGPT. So here I have a bunch of boards on the left side. If you see my cursor scroll here, on the left side I have a bunch of boards here. And then each board I have a bunch of categories. And for each category I can make a card. And then I could also link cards to each other for each category. I can invite people to a board or a card to collaborate on note taking. So this is more of like a virtual note taking tool, but really the power behind this is like keeping track of information and how it presents, how I keep track of it. So like movies and shows that I'm trying to watch. I have like watch lists, and so this is like my watching, reading, priority, listening list. And I have a lot of stuff here, aside from hundreds of papers for the work I'm doing that has to do with understanding adaptive learning in human behavior, and also how that impacts technology. So that's I'm working on a series of publications that has to do with, okay, how do we better understand modeling human behavioral complexes, like how we make decisions, how we engage with the world around us, what does that mean for technology moving forward, and what does that mean for how we can better ourselves. So I am working on like a series of publications geared towards that. So right now I have about 6 publications in the making for that. Well, I'm really focused on getting 2 published right now. Both of them are over halfway done, but anyway, I don't need to talk too much about that. For anybody else interested in learning about that, I'll provide an email address at the end. I'll write it on the board. I have a whiteboard behind me over here. Again, just to break down how Trello is really useful. Like I got hundreds of articles here, especially if I scroll down here. Hundreds and hundreds of articles that I've bookmarked, especially here. Really, like for the adaptive learning based publications I'm doing, it's well over 500 articles that I have to work with. But these are really the key articles, like more so the key articles. And then there's cards too. So the attachments, those are links to articles. These are cards. The cards have more articles in them as well. Let me get to ChatGPT and kind of go over that real quick. So I use GPT-4 for obvious reasons that I have to go through papers, publications, and I need it to go, and I need this technology to parse information most accurately. So I use a subscription version. You can still get a lot out of using the 3.5 version. There's drawbacks, like you have to, the way you prompt with it matters. So the past session I did use GPT-3. So using GPT 3.5 as an example, I came up with a prompt. So for those of you who are trying to understand what this prompt response interaction with this chatbot, like, it seems like it is a chatbot, but it's a bit more than that, because what's happening is I'm feeding it statements, right, in the form of a prompt, and it will take these statements and it's going to parse each word, right? I have a sequence of words and the words would also be known as tokens with respect to the way that that this engine is trying to understand and respond to the information that I'm presenting to it, right? So first thing I do is I come up with a prompt, ask it a question, or I could ask it a series of questions, but it's best to not throw it too much information, especially if you're using the subscription-based version, which would be version 4. Version 5 is going to come out at some point, but right now what's available is version 4. So I ask it to explain what is color, so it gives me a response. I'm not really going to go into the depth of the response. But it gives me a nice breakdown of, okay, like what is color, how we perceive color, like how it happens, blending colors, some phenomenal explanation behind what color is, what it means. And then I notice, like, because I have some understanding of like how we perceive color in the spectrum of the hydrogen atom, which I'm not going to get into, but so I asked it a question about that because it didn't really mention anything about that. And it mentioned the physics of color here, where it talks about physics of color. It gave me a response to that. So this would be what you want to do when you engage with these systems is you want to give it like a chain of prompts, right? You feed it like question by question, right? Don't feed it a whole bunch of questions, but really people who are going to leverage the most out of a platform like this, really it's really going to help people who already have an understanding of the subject matter that they're dealing with to use these engines. Although people who are new to the subject matter at hand or whatever work they're doing and they're using these engines, it's going to help a lot in terms of learning quicker. But at the end of the day, you don't want to rely on this type of engine to really handle a lot of the workload for you, because really what it's doing is it's boilerplating, right? You feed it a statement and it boilerplates context, it boilerplates a response of information based on how it fetches from its database, right? So it's trained on basically the internet. And we all remember search engines, right? I can search, color, right? I can look up color on Google. Or I could do physics of color, right? And the problem with looking up things on Google or any other search engine, right, is I do have to add some specificity in terms of, I can't just say color, right? Because if I say color, it's going to assume like whether I want a color, it's probably going to assume I want to generate colors rather than understand colors, right? So because I want to understand what color is, physics of color, right? Now I get a much more intuitive generation of web pages that I can browse through. So, to get a more intuitive understanding of how this engine's working more efficiently, not always, but sometimes it works more efficiently than a web browser, because I can provide a search term in the search engine, be it Google, for instance, and it will fetch me a bunch of web pages that are ranked based on how many how many references to the term that I made are associated with a certain page. Number one, right? So how many references does a certain page contain? How many people visited a certain page? And that is how it's going to fetch me information mainly, is how many references it makes to the term I'm looking for on the one hand, and on the other hand, what are the most visited pages. So it's going to fetch me all those pages, and that's how a search engine basically works. And I can go through all those pages, and I can keep scrolling through pages and pages and pages trying to look for what I'm looking for, or if there's certain statements that I need broken down for me. If I don't want to go through all these pages, that's what's really the beauty of an engine like ChatGPT. Now, there's other engines, there's other generative AI engines like Gemini, Claude. There's open source engines like Llama 2, which you have to throw together. You have to spend some time throwing it together, so you have to have a background in tech and programming to leverage the more open source systems. But this is even though it's sort of closed sourced, it's you can pay for a subscription to get the most out of it. If you don't pay for a subscription, well, you'll get quite a bit out of it. You can leverage GPT 3.5. Just a little sneak peek though. Yes, just to emphasize what you can really do with this system, I'll give you a little sneak peek on you leveraging the most out of this system. So using GPT-4. Now, okay. What this system is doing, though, before we get to that, right? You notice that I gave it a prompt in the beginning. And now what it does is it's going to parse the prompt into and it's going to tokenize. It's going to tokenize each word that's associated with the initial prompt I give it, right? So this is the whole prompt is a statement that is tokenized. And then what it's going to do is it's going to go through basically the database it's trained on, because what this is it's a trained engine that parses information in its database. It fetches that information, it presents it to me. Once it finds the right patterns and associations based on the prompt that I give it, it then delivers back a response based on the parsing of details, not providing me a whole lot of redundancies, or like I showed you, it saves me the trouble of basically going on a web browser. Well, I'm using a web browser, right? It's not a web browser, search engine. It's saving me the trouble of going through a search engine and just going through page by page, understanding the search, like what I can get from the search term I looked up. Instead of going through all that trouble, I can have information summarized and presented to me in a manner of how I ask it, okay, tell me what this means. And it'll just parse the information and present it, right? And the best way to leverage this, so here's a prompt that I worked on that leverages version 4, which is the paid version. And basically, I started reading a book, so what I could do is, if I'm starting a book and I need help working through the chapters or certain sections of the book, I can upload it, I can feed it the book, right? Because it might not have access directly to the book, but as it parses through the book based on what I ask it to search through, like I give it a certain page number, or I give it a section that I'm struggling with and I need elaboration on, it's going to compare that information to other information that's stored in this database, right? And it's going to average out the meanings. and it's going to get the right meaning that I'm looking for, right? I'm struggling to understand the meaning of something, and I ask it to elaborate on certain certain parts of the section in the chapter I'm working with. And what I do is I do this. Maybe this isn't the proper way to go about it, but so chain of thought prompting. You want to piece by piece feed it information. You don't want to feed it like a whole 2 paragraphs or what have you. That's not the proper way to interact with this system. But you want to feed it information, and if it doesn't provide you a satisfactory answer from the get-go, you can keep feeding it information. So like I give it a follow-up prompt on over here. Well, this is because I was working more, like as I'm working through the book, I ask it questions, right? So so there were certain things I wanted clarified. There were certain conceptual clarifications I wanted as I started the section, so it gave me a response for that. And then I worked through the book a bit more, and I asked for a little bit more clarification for pages 5 through 8, and it did so. And then I wanted more clarity, so I asked it specifically what I wanted clarity on, which is this inequality, or the construction of that inequality that I mentioned. So it provides that clarity, right? And it's great. As long as, well, it's as good as you interact with it, right? So it's not perfect. It struggles with certain types of conceptual abstractions, but the less ambiguously you provide a statement for it to parse and then respond to, the better the results, right? And you might have to do some follow-up prompting, but it keeps track of that information via session state information, right? You see all these sessions on the left-hand side, keeps track of everything I'm asking it pretty much. So, okay, that's a gist on, okay, this is what generative AI can do. This is what makes it different than a search engine. All right, now let's get to the talk of the day. So I want to talk about how can we use art's been a main inspiration for me in terms of engaging with abstractions of information, especially when I work through math books, physics books, papers, especially like when I'm writing papers too, because I'm working on a couple papers as I mentioned earlier. Art provides this really beautiful capacity for me to simplify abstractions I have going on in my head. Okay, so I have this blog here that I post art on. And this is one of the pieces right here. One that I finished recently that I was working on for a while. Now, I work on a lot of my pieces for pretty long period of time because I put a lot of thought into them, but also the real beauty of the pieces for me too is I can flip the orientation of the page around and it presents a different point of view of looking at the piece, right? So I can flip this sideways. I'm not going to do it right now because I have it on screen and on Tumblr. But basically, imagine flipping this 90 degrees, flipping it upside down, right? Gives you a different way of looking at the same piece. So that's a lot of intuitively how I structure my pieces. But more interestingly, you'll see these geometric patterns. So I have a whiteboard here, and I think let me just make sure the whiteboard is positioned right. I'll focus on the top half of the whiteboard. Okay, so let's start from the leftmost image here. So we see the region, the top left region of the piece, which seems to be a mesh of 3 boxes or squares, have you, that are kind of conjoined into each other or chained together. That's what it looks like, rather. But let's get an idea of a pattern here that is being replicated to do this. And before I get into this, there's a motivation behind how I'm constructing these pieces. And that motivation is cellular automata. Okay, so what's so interesting about cellular automata models? So Stephen Wolfram, he's a mathematical physicist. He works on trying to understand complexity and complex systems. So you can think of a complex system as one of the best examples of a complex system that I tend to give is, think of the if I take biology, for example, and I take chemistry, and then I have, boom, molecular biology, right? I have the understanding of biology not from a point of view of understanding anatomical structure and functions of life and organisms, but also taking that understanding and bridging it together with chemistry or chemical structures, right? And there's a lot that can be said about how physics really boils down to molecular, atomic, and subatomic structures of everything that exists. I'm not going to get into that right now, but that's just an example of like thinking of a complex system. Like, complex system is really thinking about how can we take concepts from different fields or different realms of understanding and bridge them together. That's one idea of thinking of a complex system, right? That we have these different dimensions and dynamics of how a system operates and can be represented in terms of its function and how the parts are interacting with each other, and how if I have a whole space of things interacting with each other, like how the functions of those things are complicating each other over time, right? So I have this idea of a state space. A state space is like, okay, what happens from time 0 to whatever, like from iteration 0 to iteration, from the first iteration to the very last iteration. And let's step into one of these. Here we go. So here's an example right here of not a lot of these rules unravel and become these really complicated triangular structures with a lot of patterns going on inside of them. And you'll notice that what's happening is a bunch of grid space is being shaded and filled out in a certain type of pattern. And the way this is able to happen is there's some rules in filling up the grid space, right? If we notice here that going from left to, so from the top, like if we notice for rule 30, right? So for the very first rule, the bottom cell, if it's not shaded, then the 3 cells above it are shaded. And then on to the right of that, if the bottom cell is shaded and there's a cell to the top, if a bottom cell is unshaded and there's a cell to the right that's unshaded, that means that the center cell is going to be shaded and then the cell to the left is going to be shaded. And then to the right of that, we see the center cell is not shaded and the bottom cell is not shaded, but the right and the left cell are shaded as a correspondence to that. And then if the center cell is not shaded, the right cell is not shaded. So that would be pattern 4, right? So we went through the first 3 patterns for Rule 30. Pattern 4 would be, okay, the left cell is shaded and the bottom cell is shaded only if the center cell and the right cell aren't shaded. So, and then the rule after that would be, okay, if the center cell is shaded and the right cell is shaded and the bottom cell is shaded, then the left cell is unshaded. And so on and so forth, right? And then there's a rule here towards at the very end where if none of the cells are shaded, then those cells are unshaded. So basically the way this unravels is I start at the very top of the grid, right, the topmost center of the grid, and I iterate all the way down to the bottom of the grid. And then that's how I get these rules. So, okay, what does it start with? It starts with the So rule 30 here has 8 rules. It starts with the rule where the center cell is shaded and the bottom cell is shaded, but the left cell and the right cell aren't shaded. So that's how it starts. And then when you step down, it goes to the very first rule where the left cell is shaded, the center cell is shaded, the right cell is shaded, but the bottom cell isn't shaded, and so on and so forth. So you can follow what's happening here based on these rules, but sometimes complexity makes it so we have to optimize what rule works best based on how the grid fills out. So it might not feel appropriate, or there might be complication to follow how the rules play out based on how much space is already shaded or unshaded. But when we start with an unshaded space, based on where we start, with Rule 30, I guess it seems we start with the center cell shaded, the bottom cell shaded, and so basically the way we start, just to make it obvious, is boom, so we start off like this for Rule 30, and then it just goes down the grid. Okay, great. So I guess this gives us some clarity on how I come up with rules so I come up with rules similarly for my pieces that are inspired by cellular automata. So let's figure out how this unravels. Let's figure out how this unravels. So starting with the top left region, I have this T-shaped object, right? I have like perpendicularity, right? You can imagine like perpendicular relationship between two lines, right? I have 90-degree angle formed between the lines, right? I have 90 degrees here on both sides, right? So you can imagine like 90 degrees. If you remember your geometry class, basic geometry class, or if you took a basic geometry class. Okay, so I have this T shape, and basically I'm taking this T shape and I'm figuring out how to replicate this shape in different ways. There's so many ways I can replicate this shape on the canvas, but one of the ways that might stand out, if I take this shape right here, right, I replicate that T shape. Then I'm noticing over here, I'm noticing a lot of that object, right? So you can imagine how this T shape is replicated all over the canvas. So that's a basic idea of like what I did for each region was come up with a different shape to replicate within that region. So for the bottom right over here, which looks quite appealing, that's probably among my favorite of the regions in this piece. It's like a Y shape, right? And you can imagine, oh, I'm sorry, I wrote it upside down. upside down Y shape. Right, and then you can imagine, okay, what can I do with this, right? Right, I could do all, I could make like this tree structure, or I could, and so on and so forth. So the motivation behind how I construct my pieces here is I come up with some very simple shape to replicate throughout different regions of the piece. It might not be the same exact shape, like throughout the entirety of the piece. So I'll go through another example. Whoops. Okay, so let's take a look. So here's another cool example, like kind of simple but really elegant. Basically, I take a rectangle and I make another rectangle at the corner of a rectangle, and so on and so forth. This pattern kind of I figure out a way to replicate this pattern, right? I mean, and really the beauty of this is that there's so many ways I can replicate how the rectangle is formed at the corner of another rectangle in this way. But the idea is to take a shape, or to take a simple rule of how shapes associate with each other in the piece and replicate that. So I'll go through one more, but like you can see how, and I can change the size of how the rectangles are going to enlarge or take up space, right? So let's do one more. Well, just likes to do that. Okay. I'll show you guys one of my favorite ones here. One of the ones I'm most proud of. Okay. So I have two different, so here I have a bunch of triangles, a bunch of right triangles really, and the bottom half of the bottom half here is probably, it seems probably more complicated than the top half, but really what's happening is I have a triangle. I have like a right hand triangle right there, right? I make another right hand triangle. I think I did that right. Oh. Well, you get the idea. I have triangles within triangles, right? This is, and basically I have like this alternate iterative process of shading the outermost triangle, and then I could do something like this where I make another triangle. I put another triangle inside of it, and I shade the innermost triangle. And there's all different kinds of ways I can replicate this pattern. I do add certain aesthetic nuances, as you can see, so like orthogonality, like 90, having the triangles 90 degrees, associated like 90 degrees, in some way with reference to each other, at least the big triangles that are containing the smaller triangles. And then there's another pattern. This is the one that I think is more difficult to understand. So I'll have like a big triangle, and then I will have a smaller triangle take shape under it that almost forms a square. And I have this, again, this alternate shading pattern. And then I can connect these triangles. Let's say I have a smaller. Usually I take my time putting these pieces together, but the basic idea is I might have the big triangle here that's unshaded, and then the smaller one right under it that almost forms a square. I shade that, and I'll flip that, and I'll mean, okay, it's going to be the bigger one that gets shaded instead of the smaller one. And I might add some randomness to the piece to add aesthetic quality to it, like adding a triangle over here that doesn't have another triangle connecting to it in the same way. And again, this is based on coming up with like simple rules. So cellular automata, as I've mentioned, where I fill out cells of a grid. And basically, I have certain rules that, based on how I start with the grid, it's going to fill up a certain way. But that's essentially the session. We went over how I came up with what I'll call my art at this point, the art that I draw. I came up with this name, procedurally generated art, or PGAs. So I come up with a procedure, I generate a whole bunch of, I come up with this rule of like how different shapes connect, and then I generate some abstraction of that on a canvas. And that's basically it. And I think I've covered up everything that I wanted to cover today. I'm running over. Thanks for watching the video, and until next time, thank you.